Welcome to Channel Academy. In today's class, we'll be talking about lowest common multiple, LCM. By the end of this class, you should be able to solve questions like this. So questions like this: two bells ring at interval of 12 minutes and 18 minutes. If they first ring together at 8 a.m., at what time will they next ring together? So these are the kind of questions you should be able to attempt. And so let's begin our class. LCM. LCM is known as the lowest common multiple, and sometimes it is also called the least common multiple. Alright, before we move into calculation or method of finding the LCM, I would like to define some key factors that makes up this LCM, which are the multiple and then common multiple. Multiples are numbers you get when you multiply a number by 1, 2, 3, 4, or 5. For example, the multiple of 2 are 2. 2 multiplied by 1 is 2. 2 multiplied by 2 is 4. 2 multiplied by 3 is 6. 8 by 4, and so on. So these are the multiple of 2. Another perfect example we can also have for multiple is if you have 3, the multiple of 3 are 3, 6, 9, 12, 15, and so on. So these are multiple. So multiples are number you get when you multiply a number by 1, 2, 3, 4, 5, 6, and so on. If you're confused of how we got these multiples, so let me quickly break it down simpler. So 3 multiplied by 1 is 3. 3 multiplied by 2 is 6. So that's how we got this 6. This 9 is multiplied by 3. This 12 is multiplied by 4. And this 15 is by 5. Same thing for these 2, 4, 6, 8, and 10, and so on. So these are multiple. The next thing we want to define is common multiple. So what are common multiple? So common multiple are multiple that appear in both lists. So let's go back to definition of multiple. So if you look at the multiple of 2 and 3, what are the numbers that appear? If you look closely, you see that 6 appeared here and 6 appear here. 6 appeared in 3 and it also appear in 2. However, we can keep expanding the multiple because it's infinity. But in this list we just wrote down, the list we gave, we have 2, 4, 6, 8, 10 for the multiple of 2, and we have 3, 6, 9, 12, 15 for the multiple of 3. So the common multiple between 2 and 3 is 6. So therefore we can say 6 is the common multiple between 2 and 3. So let's give another example. Let's say we have 4. So what are the multiple for 4? We have 4, 8, 12, 16, 20, 24, 28, 32, and so on. So we also have 6. So what are the common multiple for 6? We have 6, 12, 18, 24, 36, 42, 48. So these are the multiple of 6 and 4. So if you look closely, do they have any common multiple? 4 and 6, can you see any common multiple? All right, so we have 12. Is there any other one? Look closely. We have 24. Can you see any other common multiple? All right, in this example we have 2 common multiple in the list we have just given, but however there are more than 2 because the set still keeps going. So we can say we have the common multiple between 4 and 6 are, we have 12, we have 24, and so on. So in this list we gave, we only have 2, but however there are more than 2. If we had given all the list, you would have seen numbers such as 36 and other numbers like that. So these are the common multiple. All right, I haven't defined that, so we can say LCM, it is the smallest multiple that 2 or more numbers have in common. So let's go. So between 12 and 24, which of them is the least or lowest in terms of value? 12, of course. So 12 is the LCM because it is the lowest common multiple or the least common multiple. Let's take some example. Example 1, LCM of 3 and 5. So how can we find the LCM of 3 and 5? What we'll do is, what are the multiple of 3? The multiple of 3 are 3, 6, 9, 12, 15, 18, 21, and so on. So what are the multiple of 5? The multiple of 5 is 5, 10, 15, 20, 25, 30, 35, and so on. Okay, so what are the common multiple between 3 and 5? What are the common multiple? Look closely. Look closely. So we have 15. Can you find any other one in this list? So our LCM is 15. LCM is 15 because it is the least common multiple we have. Okay, let's take another example. If we have LCM of 8 and 12. So the first thing we'll do is to look for the multiple of 8 and the multiple of 12. So the multiple of 8, say 8, we have 8, 16, 24, 32, 40, 48, 56, 64, and so on. So the multiple of 12, we have 12, 24, 36, 48, 60, 72, and so on. All right, so look closely. What are the common multiple between 8 and 12? What are the common multiple? Okay, we have 24. 24. Is there any other common multiple? We have 48 and 48. So in this set we have given, the common multiple are 24, 48, and so on. So what is the least common multiple? 24 is the least because it's lesser than, is the smallest among the common multiple. So the least or the lowest multiple is 24. So let's move on to the method of finding the LCM. The first method we'll talk about is listing method. In this method, we write out the multiples of each number, then pick the smallest common one. So let's take some example. Find the LCM of 4 and 8. So the first thing we'll do is write down the multiple of 4 and the multiples of 8. So 4 and the multiple of 8. So what are the multiple of 4? We have 4, 8, 12, 16, 20, 24, 28, and so on. So the multiple of 8 are 8, 16, 24, 32, 40, 48, and so on. So these are the multiple of 4 and 8. So the listing method says that we write down the multiples. Now we've already written the multiples down. Then we pick the smallest common one among them. So the smallest multiple among 4 and 8 is 8. So our LCM is 8 using the listing method. Alright, so let's talk about the next method. So the next method is the prime factorization method. In this method, we break each number into prime factor and take the highest power of each prime. So let's take an example. Find all right, so if I am sure you've watched our previous video that talked about types of number, we talked about factors there, and then we spoke a bit about the prime numbers. So the factors of 12, we have 2 multiplied by 2 multiplied by 3. This will give us 12. So 2 multiplied by 2 is 4. 4 multiplied by 3 is 12. So these are the factors of 12. So what are the factors of 18? The factors of 18 is 2 multiplied by 3 multiplied by 3. We can then express this as 2 raised to the power of 2 multiplied by 3. Now 2 raised to the power of 2 is same thing as 2 multiplied by 2. Okay, so we can write this then as 2 multiplied by 3 raised to the power of 2. So these are the prime factors. All right, so let's see what the prime factorization method says. It says we break each of this number into prime factors. So we've broken it into prime factors and take the highest power of each of them. So this and this is our answer. So we can say our LCM is equal 2 raised to the power of 2 multiplied by 3 raised to the power of 2, which is equal to 2 multiplied by 2 multiplied by 3 multiplied by 3. And our result will be 2 multiplied by 2 is 4. 4 multiplied by 3 is 12. 12 multiplied by 3 is 36. So our LCM is 36. Now is what the prime factorization is talking about. So please, if you've not watched our previous video that talked about prime numbers and factors, please do well to go and watch that, because with that you'll be able to understand what we are doing properly in this method. So the method says we break each number into prime factor and take the highest power of each prime. All right, so let's move on to the next method, short division method. The division method divides the number by prime number step by step until all becomes 1, and then multiply the divisor to get the LCM. Let's take some example. Okay, so this method says we divide the number by prime numbers step by step until all becomes 1. So what we'll do is we'll draw a line, eight, 12 and 20. We'll start from the least number 2. Check if 2 can divide any of them. Of course 2 can. So 2. If 2 divides 8, the result will be 4. If 2 divides 12, the result will be 6. If 2 divides 20, the result will be 10. We check again. Can 2 go into any of them and again? Yes. So 2. If 2 divides 4, the result is 2. If 2 divides 6, the result is 3. If 2 divides 10, the result is 5. So we check again. Can 2 divide anyone? Yes, 2 can also go again. 2. If 2 divides 2, the result is 1. Can 2 divide 3? No. So bring down the 3. Can 2 divide 5? No. So bring down the 5. What can divide again? Can 2 go into any of them? No. So how about 3? Yes, 3 can divide. So 3 into 1. Yes, 1. 3 into 3, we have 1. 3 into 5, 3 cannot. So we just put 5. So what else can divide? Can 4 go? 4 cannot divide, so we'll put 5. 5 divides 1. Cannot, just 1. Cannot, so 1. And then 1. So the division method says we now multiply the divisor to get the LCM. So let's multiply the divisor. We have, now these are the divisor. These are the divisor. So we multiply them. So our LCM is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3 multiply by 5. So our results will be 120. So 120 is our LCM. So we'll take another example. Alright, so find the LCM of 5, 16 and 32. Alright, so I'm going to be using the division method. I'm using the division method because it is best for large number and many values. So solution, we draw out our line. So 5, 16 and 32. So check carefully. Can 2 divide any of the value there? Yes, 2 can divide 16 and 32. So if 2 goes, 2 cannot divide 5. So if 2 divides 16, the answer is 8. And if 2 divides 32, the answer is 16. Alright, so let's see if 2 can divide anyone again. Yes, 2 can still go. Put 2, 5. If 2 divides 8, the answer is 4. If 2 divides 16, the answer is 8. 2 can still divide. So 2, we have 5. Then 4. If 2 divides 4, the answer is 2. If 2 divides 8, the answer is 4. So 2 can still divide. 2, we have 5. 2 divides 2, we have 1. 2 divides 4, we have 2. 2 can still divide again. 2, we have 5. 1, 1. So 2 cannot divide any longer. Can 3 divide? No. How about 4? It can't. How about 5? Yes, 5 can divide. So we use 5. 5 divides 5, we have 1. So we have 1, 1, 1. Alright, so we multiply the divisor. So our LCM is the multiplication of the divisor, which are these numbers. So we multiply these numbers. So 2 multiplied by 2 multiplied by 2 multiplied by 2 by 2 multiplied by 5 equal to 160. So 160 is our answer. So the LCM is 160. The next question we are going to be solving is this number 1. 2 bells ring at interval of 12 minutes and 18 minutes. If they first ring together at 8 a.m., at what time will they next ring together? The first thing we'll do is to look for the LCM of 12 minutes and 18 minutes. So we're going to use the multiple. So the multiple of 12 and the multiple of 18. So the multiple of 12 are 12, 24, 36, 48, 60, and so on. So the multiple of 18 are 18, 36, 54, 74, 90, and so on. So if you look closely, what is the common multiple between the multiples of 12 and 18? We have 36. So, and it is the least common multiple. So our LCM is equal to 36 minutes. Don't forget, it's not just 12 or 18. It is 12 minutes, 18 minutes. So our answer will be 36 minutes. So this bell will ring together every 36 minutes. So let me take this off so we can have space. Ring every 36 minutes. The bell will ring together. All right, so every 36 minutes the bell will ring together, but the question is saying at what time will they next ring together? They're asking us the time. So the first time they rang together was 8 a.m. so the next time will be 8 a.m. plus 36 minutes. So 8 a.m. plus 36 minutes will give us 8:36 a.m. So the next time this bell will be ringing together is 8:36 a.m. So if the bell rings together every 36 minutes, it means that the next time after 8 a.m. will be 8:36 a.m. That's when the bell will ring together. We will solve number 2 and number 3 in our next video after we've talked about the HCF, the highest common factor. Okay, and thank you for watching this video, and please, if you have not subscribed to our channel, please do well to do so, and don't forget to share and drop your comment. Thank you. Do have a lovely time. Bye.